To many, the Soviet space shuttle, or Buran, was just a copy of the NASA one. It looked surprisingly similar and was meant to do similar things, but beyond the looks, the two were really quite different. Not only in the shuttle vehicles themselves, but also the way they got into space. In many ways, the Buran could be seen as Space Shuttle 2.0. To build big things in space, you have to have an affordable way to get off the ground. As spectacular as the American Apollo-era rockets were on camera, they were hardly efficient. The Titan 3C cost around $4,500 in 1972's currency to deliver each kilogram of hardware into low Earth orbit. The Saturn 1B could lift a larger payload, but it cost around $6,800 per kilogram. Adjusted for inflation, that's around $40,000 per kilogram in today's money, or $40 million per tonne. NASA aimed to solve this problem with a space truck, the STS, or the Space Transport System, that eventually became known as the Space Shuttle. Originally, the shuttle was designed to fly up to 60 missions per year to low Earth orbit at a cost of around just $453 per kilogram, less than a tenth of the cost of rocket launches at the time. This would enable NASA to construct space stations or large modular spacecraft for manned missions to other planets. More worryingly for the Soviets, they believed it would have a greater military role, like capturing and returning satellites from orbit or deploying space weapons. When the STS was announced in 1972, Soviet rocket engineers were hardly concerned with efficiencies. They were still working on Sergei Korolyov's giant N-1 rocket. Korolyov had died 6 years earlier, and his deputy, Vasily Mishin, had taken his place. The N-1 still carried the Soviet dream to land cosmonauts on the moon, but after 4 failures in 4 test launches, the N-1 program was suspended in 1974. The Soviet leadership replaced the now disgraced chief designer Vasily Mishin with the rocket engineer Valentin Glushko, who went to work on an alternative program of lunar missions using the smaller Proton rocket. However, in early 1976, Glushko received instructions to develop a symmetrical response to the American shuttle. Over 600 Soviet institutions were enlisted to work on the huge project. The new spacecraft would be called Buran, which translates into English as snowstorm or blizzard. On the outside, Buran looked like a copy of NASA's Shuttle, which wasn't surprising as much of the non-confidential plans had been on public view for years. This allowed the Soviets to adapt a proven airframe which saved the engineers precious time and allowed them to improve on the American design. Buran would allow the Soviets to leapfrog to Shuttle 2.0 with greater payload capacity, mission flexibility and better crew safety. The major difference between the US Shuttle and the Buran was that the Buran was unpowered. It didn't have main engines attached to it like the US Shuttle. Instead, it would be attached to a giant heavy-lift rocket. Doing this meant that Buran not only had a larger payload of 30 tons to the US Shuttle's 24, but it could also be turned around much quicker. It also did away with the need for the solid rocket boosters that the US Shuttle had used. These were part a low-cost fix to get extra thrust and a political move to keep ballistic missile makers in the space program. Powerful as the thrusters were, they were not controllable once ignited, and due to a sub-zero temperature launch, the O-rings of one booster failed, which led to the loss of the Space Shuttle Challenger. One of the biggest problems slowing down the US Shuttle launches was that the main engines had to be removed and refurbished after each mission. This was a major job which took months to complete. The Buran, on the other hand, had just thrusters which it used for manoeuvring in orbit and which were rated for 66 flights without replacement. It was also going to use 2 turbojet engines, the same ones that were used in the Sukhoi 27 fighter. The original idea was that these would give it a much greater range if it couldn't land at the designated airbase, or it could make several attempts at a landing if it detected a problem. It could also take off and fly around like a normal plane from any airbase. Originally, these turbojets were to be placed at the base of the tail fin. It was then realised that 2 were not enough, so 2 more were added below the first 2. But difficulties in protecting them from the heat of re-entry along with the extra fuel, equipment and weight which they added, caused delays and cost overruns, which meant that they were not ready for the first flight, and the Buran had to operate in glider mode without them. The US Shuttle, on the other hand, could not use its main engines for landing, so it was always going to be an unpowered glider, and therefore could only have one chance to get its landing right. The Buran was also designed from the outset to be flown completely automatically without any crew if required. If the crew were on board, the pilot and the co-pilot had ejection seats, something which had been ditched in the US Shuttle. But if Buran was the headline, then XLOCQw5s9Uw was interested in the fine print too. He was determined to keep the Soviet route open to the moon. With this in mind, he tasked his design bureau with building an independent rocket to launch Buran as a payload. This way, the Soviet shuttle would be much closer to the design goals of the original American STS shuttle. This new rocket, called Energia, weighed almost as much as the scrapped N1 at 2,500 tons on the launch pad, to the N1's 2,750 tons. Energia had enough power to either launch the Buran into orbit with a 30-ton payload or launch up to 100 tons without the orbiter, even more than the N1's planned 95 tons. Energia achieved its incredible power by staging 4 booster segments, separating from a central core during the launch, with each booster carrying an RD-170, the most powerful rocket engine in the world. Now, many will say that the Saturn V F1 engines made by Rocketdyne were the most powerful. Well, they were the most powerful single combustion chamber engines, but the RD-170 is still a single engine, but it used 4 chambers instead of 1 to get around the issue of combustion instability, a problem that gets worse as the chamber size increases and can literally blow the engines apart. The Americans used baffles in the rocket nozzle, which allowed them to keep the large single chamber but at the expense of power, because they took up space that would have otherwise been filled with more injector holes for fuel and liquid oxygen. The 4 chambers of the RD-170 supplied 7,900 kilonewtons of thrust in a vacuum, even more powerful than the 7,700 kilonewtons for the F1. Soviet engineers also achieved higher chamber pressures in the RD-170 than the equivalent American engines, resulting in greater fuel efficiency from the ground. In 1986, after 10 years of development and testing, Energia was ready for launch. But as the rocket neared completion, there remained a problem. Buran was still years away from being ready. To test the new Soviet launcher, a repurposed TKS module was loaded with science experiments, including elements of the SCIF CO2 laser weapon. The 80-ton payload was given an ominous black coat of paint and named Polyus. When the Energia rocket lifted off for the first time on the 15th of May 1987, the huge rocket set off at an angle. Fortunately, 3 seconds later, the guidance system corrected the trajectory, continuing a path into the sky as planned. Energia's first launch was a success. The payload separated at its target altitude, ready to carry out a brief orbital insertion burn. However, due to a sensor malfunction, Polyus rotated further than intended before its burn, falling back into the Pacific Ocean. Still, XLOCQw5s monster rocket had shown that it could do what the N1 could not. The USSR now had a proven super heavy lift vehicle, and the next task was to use the Energia to launch Buran. On November 15, 1988, 1 year before the fall of the Berlin Wall, the pride of the Soviet space industry was prepared on a pad for the long-awaited maiden launch. The first test flight of the Buran was to be an unmanned mission operated entirely by its onboard computers. At 8 AM local time, Energia lifted its orbiter to an altitude of just over 250 kilometers. Buran orbited the Earth twice in a little over 3 hours, then slowed to re-enter the atmosphere. There, its automatic systems detected that there were high crosswinds, and it therefore made a second approach at the airfield at Baikonur. Even battling a strong crosswind, the Buran touched down just 10 meters from the target mark on the runway. Images of Buran's maiden flight shocked and impressed the world, who hadn't imagined that the USSR could build their own space shuttle. But plans were already in place to go further. With a second orbiter, the K2 Titcher, or Little Bird, scheduled to launch in 1991. A third orbiter, K3 Baikal, named after the world's deepest lake in Siberia, was to make the first manned flight in 1994. An improved Energia 2 rocket system was also planned, which would have been fully reusable and capable of launching a payload of 175 tons to the moon or beyond. The center core booster would use Sanger's 1933 antipodal aircraft method to skip off the upper atmosphere and make its way around the world and back to the launch area. Also, the detachable boosters would fall away and open their folding wings and be able to glide like a plane back to an airfield. But sadly, both Buran and its huge rocket would never fly again. By 1989, the USSR was already beginning to unravel. When the Soviet Union broke up 2 years later, Buran and Energia gathered dust in long-term storage. In many ways, the Buran and the Energia were a solution to a problem that no longer existed, and something that the new Russia could no longer afford. As the new Russian space agency struggled to raise funds, Buran and Energia were displayed as a gargantuan exhibit to impress tourists and media who visited the Baikonur Cosmodrome. However, by 2001, poor maintenance had led to water leaking through the roof of Building 112 onto the spacecraft 75 meters below. On the 12th of May 2002, a repair team climbed onto the roof after heavy rains. At 9:20 a.m. in the morning, with a huge crash, the roof collapsed, completely destroying the K1 Buran and the Energia, and also killing 8 workers. Although the vast costs of developing the Buran might appear to have been a tragic waste, the technological legacy of the Energia lives on. Variants of the RD-170 engine are currently in use on the current family of Zenit rockets. The American Atlas V first stage is powered by the RD-180, another adaptation of the remarkable design. After the Space Shuttle Columbia disaster in 2003 and the grounding of all the US shuttles, it was wondered whether the Buran could be brought back, but by then both the vehicles and the equipment had fallen into disrepair or had been used for other projects. In 2011, when the US shuttles were retired, the idea was floated once again as a cheaper way to gain a shuttle service instead of designing a new vehicle from scratch. But again, it came to nothing, and the dream of a Russian space shuttle went the same way as the US one. So thanks for watching. I'd just like to say thank you to all our patrons for their ongoing support and to those who voted this video as their most wanted. If you're interested in supporting the channel, you can find out more by clicking on the link now showing. So thanks again for watching, and please subscribe, thumbs up and share.